thank you everybody for joining. In this webinar, I will be answering the question why medical device companies are rubbish at requirements. But I will also show you some useful tips on how to improve in the areas of managing and writing requirements. So stay tuned for that. But before I get to that, let me spend 23 seconds, to be precise, on presenting Medical Device HQ. So I'm the founder of Medical Device HQ, and my company trained more than 2,500 medical device professionals from competent authorities, notified bodies, and medical device manufacturers last year. And one thing that makes Medical Device HQ unique is that our instructors have all participated in writing the standards that we have to work according to. So in my case, I've been involved in writing ISO 13.5 and ISO 14901 and IC 62366-1. Lots of numbers. Anyhow, I would be happy to connect with you on LinkedIn. So don't hesitate to look for Peter Sebelius on LinkedIn and add me, or follow Medical Device HQ's company page on LinkedIn. There are some useful things I will be posting there. So I strongly recommend you to do that. Now, a lot of what I will be presenting today is coming from a new course that I'm launching today. It's called Introduction to Medical Device Requirements Engineering. And just to be clear, that's not the course that Carl was mentioning before, which is an introductory course to the medical device industry. So we need to keep those two separate. But this is very much coming from that course that we will be talking about. Now, if you're curious about that course, you can go to medicaldevicehq.com/RE, as in requirements engineering. Now, let's get to it. That was all the introduction there were. So are requirements important? Now, in my experience, and this is really sad, a lot of medical device companies are working with requirements, not because they see the value in it, but because they have to. They seem to ignore that working with requirements is one of the most, or maybe even the most, crucial aspect of systems engineering. And one thing that supports this claim or statement that I'm making is that when I have courses on design control, I've asked hundreds of people the same questions. I ask them, how many of you have been involved in risk management? And then I ask how many of the participants have formal training on risk management. And usually about 90% would say that they have training on risk management. Then I ask the same questions, but about writing requirements. How many of you have been involved in that? And it's almost always as many as have been involved in risk management work. And then when I ask how many have formal training on this, what do you think happens? It becomes very silent, unfortunately. There's very rarely anyone who has participated in some kind of formal training on writing requirements. And I personally think this is really depressing, because writing requirements is such a critical task if you want to be successful with product development of medical devices. And it's a task that requires both knowledge and skill if it's to be done properly and successfully. Now, I would be very happy, since we have all access to the chat, if you wrote a few words, if you share my view on this or my observation. Is this also your experience? Feel free to chip in on that in the chat. It would be great to hear. I will also be happy if you disagree, because that means some of you actually do have training to a larger degree. So that would be great. So why are there so few with training on how to write requirements, while it on the same time is so important to get it right? Well, I believe there's a number of reasons. One is that there are virtually no courses on writing requirements specifically for medical device professionals. In fact, as far as I can tell, the course that I'm launching today is the only one in the world. But there is another more depressing reason, I think, and that is, like I mentioned before, that many medical device companies, they simply don't see the value in writing requirements properly. It's more of a mandatory thing. You know, they read the standard and say, oh, we have to do this, but not everyone sees the point or the value. And writing requirements properly is obviously adding tremendous amounts of value. And the last reason, I think, is that whereas auditors typically would ask for training or records of training for both risk management and internal auditing, for example, very rarely will they ask for records relating to training on writing requirements. So there is not any push from the auditors to get trained in this area, unfortunately. And actually, I think most auditors don't have any training in this area themselves either. So those are the reasons I believe that we are in this area. And I can say also that a lot of significant and costly mistakes are made in the area of writing requirements, regretfully. Now, if I were to group the kind of, or the issues that I see among medical device companies relating to writing requirements, I would say that there are two main problems area or pain points. The first one is that requirements end up in the wrong processes. It could be that you find design outputs amongst the design inputs, or project requirements end up being design input requirements. And there are so many mix-ups. And when you try to push these different types of requirements through the wrong processes, it is utterly confusing. And I will come back to why in a while. But this is the first problem. The second pain point is that requirements have poor quality. And then I refer to the way they are written. They do not at all meet the requirements of ISO 13.5, which actually specifies a few things about the requirements, because they say that they should be complete and unambiguous, for example. And if you compare to requirements engineering best practices, the results are even worse. Then there aren't many boxes to tick at all, actually. So this is the backdrop for what is to come in this webinar. Now, so I would like to shift focus now from the problems and going over to solutions to these issues and provide you with some really useful insights, hopefully. And we'll start with number one, with requirements ending up in the wrong processes. Now, one needs to understand how many different types of requirements exist for any new product development project that you implement in a medical device organization. So I've made an overview that shows you the majority of these different types of requirements. And we won't have time to dig into each and every one of them, but I want to show you the complexity and which also then leads to the challenges that you may experience if you are to categorize requirements for a new medical device. So on the left-hand side, you can see that there are norms and standards or sources of requirements, and then there are categories and some examples of requirements, and on the right-hand side, documents that these different types of requirements normally should end up in. So, and if we continue, I think most of us, when we think about writing requirements, are thinking about user needs and design inputs, and you can see them here. But there is obviously so much more to it. You write requirements when validating processes. You write requirements when validating software that is used in your quality management system. And risk control options that are coming from, or risk controls that are coming from your risk management process should be part of your design and development inputs as well. So we write these things in so many different areas. And there are mandatory requirements from the IVDR and the IVDR. And by that, I'm thinking of the GSPRs, the General Safety and Performance Requirements. And lastly, sometimes, and these may actually be equally important, there are requirements from the business side of things, for example, commercial product requirements and project requirements. And ultimately, it's the project manager's responsibility to ensure that all these requirements have been properly categorized or grouped and managed. Doesn't necessarily mean that the project manager, him or herself, has to do it, but it's ultimately the responsibility of the project manager. Usually it will involve other experts, such as usability engineers or requirements engineers or whatever expertise is required to get this right. So this can be a little bit overwhelming, but let me try to make it a little bit simpler for you. So when I talk about categorization of requirements, I use a metaphor, which is to talk about buckets. Now, these buckets that you can see here typically represent different types of requirements that will be processed differently depending on their nature, and they should usually also end up in different documents. And the point is that you should manage to get the requirements into the right buckets or cups, as in this image, and that can be as fun as these folks seem to be having. And in this case, when you're looking at something that is, for example, a risk control measure, you should put it in the risk control bucket. Or to speak of documents, in my case, I would refer to it as the hazard traceability matrix. And it is important to get this right because the different types of requirements should be going through different processes. And let me show you what I mean by that. So let's start with a user need. A user need must be validated in simulated or real environment using production units or equivalent. A design input requirement must be verified, but that does not have to be done using production units or equivalent. Remember that you can be performing design verification on subsystems and you can use various methods, for example, review or analysis or testing. It's all up to you. And if we then instead talk about risk controls or risk control measures, you need to verify the effectiveness of them as well as that they have been implemented. And lastly, if there is a user interface requirement from your usability engineering process, it should be included in the summative evaluation, which can be done either theoretically or practically, actually. And the purpose of the summative evaluation is to show that there are no unacceptable risks remaining from the user interface. This means that if you have a risk control measure and you try to route that through your design verification, there's nothing that ensures that you verify the implementation, right? Because there is no such question in your regular design verification. Or if you put in risk control measures as user needs, then there's likely to be some kind of risk behind it. I mean, that's the nature of a risk control. There's firstly a risk and then a risk control measure, which means that that should be recorded in the risk assessment, and probabilities and severities should be estimated both before and after risk control measures. And if the risk control measure is recorded just as a user need, none of these things will be done, or maybe they are done, but it's not connected and there's no trace between them. So you really should try to put the requirements in their respective context and category. That's really important. So which buckets should you then have? Well, I typically work with about 8 buckets, depending on situation. And you have then user needs, design input, risk controls, user interface requirements, GSPRs, process requirements, business requirements relating to the product itself, or project requirements. And I think these terms or categories are quite accepted, generally speaking. And in that context, I want to say that unless you have a really good reason, I recommend you to not come up with your own buckets or terms that are not coming from terms or standards or industry best practices. I sometimes do come across companies that have invented their own types of requirements, while on the same time, they are not entirely clear on where these new terms fit into the regulatory context. So, for example, this clinical user requirement. And you start wondering, is that a user need, or is it a clinical claim, or what is it? So I definitely do not recommend that you come up with these home-invented terms. Another example is user needs, where there is a really good term, user needs. It's widely accepted. And some companies, they keep on changing to slightly different terms for the same thing. I don't think one should. So categorizing the requirements, putting them in the right process is super important, facilitates the process, makes it a whole lot less confusing. Now let's switch gears to characteristics of requirements. If you have taken my design control course, and I think a few of you who are listening in today have, you know that I bring up characteristics that apply to requirements. And requirements, they should be necessary, appropriate, unambiguous, complete, singular, feasible, verifiable, and conforming. These characteristics, they apply to individual requirements, but they're also characteristics for sets of requirements. Because even if you look at just one requirement and that requirement is worded perfectly, if you have another requirement that is overlapping or contradicting the first, obviously that's not a good thing. So there are also characteristics that apply to whole sets of requirements, and they are that the requirements shall be complete, consistent, feasible, comprehensible, and able to be validated. Now, these characteristics are from INCOSE guidelines on writing requirements. So to achieve these characteristics, there are a lot of rules that you should apply. But before getting to the rules, I wanted to match these characteristics with or against the requirements of the ISO 13485. And let's see if we find something that is common between the two. And as it so happens, there are a number of things actually that are shared between INCOSE guidelines and ISO 13485. And ISO 13485 requires the design and development inputs to be complete, unambiguous, able to be verified or validated, and not in conflict with each other. Now, if you don't know what these things mean, maybe you should worry a bit, because these things are required from the ISO 13485. And if you don't believe me, I have copied the standard here, so you can see the words here, exactly what the standard is saying about it. Now, what you see here is a mind map that I've done with the characteristics and rules that I've included in my course. And what I've done is that I painted some of these things yellow, and that indicates that it's something that is mentioned in the ISO 13485, either directly on the high level with unambiguous and complete, or indirectly then, because these are rules that should be applied to achieve complete or unambiguous requirements. And when it comes to non-conflicting, that's actually a hidden underneath the consistent characteristic if you use INCOSE guideline terminology. I've also added a few things because sometimes I find requirements that are not even design inputs, they are design outputs, but they are, for some reason, they appear among the design inputs, which should be avoided, obviously. So my next thing that I will be doing here is to jump into a little bit of examples on the application of these rules and principles, and see if you can spot the errors that I've made in a few example requirements, and then how we can improve them. So stay tuned for that. Here we have a bad example on the left-hand side. The XMED balloon catheter material shall be manufactured using polyethylene 80AE. Now, I will give you a second to think about what's wrong with this one. It is indeed a requirement, right? But the problem is that this requirement should not be found among your design and development inputs, because this should be on a drawing. It's not a design input requirement, it's an output. Regretfully, I find a lot of that, these examples. Now, instead, the design input requirement should be that the XMED balloon catheter material shall maybe then have a tensile strength of at least 28 megapascals. Then the designers can select polyethylene 80 maybe based on that and other requirements. And like I said, I see this all the time when I'm reviewing requirement traceability matrices and equivalent documents from various medical device companies. It's a very common problem. Here's another requirement. The software system should not allow external users to access the patient information. Here we would have to assume maybe that it's a SAMD or software product. The problem with this requirement is that it includes a negative. It says not allow. This should be avoided. Now, I'm not saying that there couldn't be exceptions to this rule, but in this case, it's particularly important to avoid the word not, and I will tell you why in a second. Because the way you should be improving this negative requirement is to say that the software system shall only allow employees to access the patient information. And this is an improvement, because in the previous bad example, you are excluding just one category, right? External users from accessing the patient information. But in theory, there could be a huge amount of other groups, which means that you're just preventing one group from accessing the patient information. In the good example, we sort of turned it around and said, well, there is only one group that should have access, and every other group is excluded, which makes it a whole lot less ambiguous. So you should turn it around this way. That's definitely the way to go. And the way you can resolve problems with requirements that includes not or that are generally negative is to use words like only or prohibit or limit. That's a good trick to make them to not make them negative or making them positive. Would be great fun to hear how many of you have not in your design input requirements. Feel free to use the chat again if you like, and let me know how many nots you have. Here we have another example. The XMED device shall have as low weight as possible. What does that mean? As low as possible. Remember that the purpose of requirements engineering and writing requirements is to ensure that there is a mutual understanding of what to expect between stakeholders on what the medical device will be like once it has been developed. And I can promise you that when you ask product managers that are responsible for marketing this medical device, as low as possible means a lot less weight compared to what the engineers are thinking of, right? They are definitely not thinking of the same thing. It's the same thing when you say it's going to be finished in June. The engineers think of the 30th of June, and the project manager and marketing people, they think of 1st of June, right? There's always a difference. And this is a source of miscommunication and disappointment and missed expectations. So what you should be doing here is to instead make it quantified or measurable. And what this is called when you have these kind of statement is that it's an escape clause. And there are many variations of that. We'll actually look at a few in a second here. So a better example would be to say that the XMED device shall weigh less than TBD kilograms or to be determined kilograms. Should you use TBD? Yes, for a while you can. Obviously, when you start your verification or things like that, make sure you've sorted it out. It should be defined before you start your design verification or validation. But for a while, you can have it like that. So generally speaking, I would say that the things I've shown you now, the problems with these requirements, would notified body auditors pick up on that? Well, quite rarely. But here, I would say that there is a significant risk that you would have a non-conformity if you write a requirement with this kind of escape clause, because the auditor might pick up on the lack of clear acceptance criteria and say, well, we don't know when this is acceptable or not, which is a good point. So this you should definitely avoid if you want to avoid non-conformities. If you want to see more examples of escape clauses, I have a recommended read for you. And now you might think that I'm going to be referring to some guideline or published article, but I'm not. No, I'm going to refer you to the medical device regulation. And this is the time where I'm starting to get even more cynical. You might be aware of Section 2 in the GSBRs, which is about reducing risk as far as possible. There you have not one escape clause, but actually a long list, because the authors of the MDR, they managed to squeeze in no less than 7 variations of the term as far as possible. Yeah, which also makes, by the way, these requirements inconsistent, which is a characteristic that applies to groups of requirements, because you should phrase them the same way, but not the MDR authors. No, no, no. They managed to write reduced as far as possible, reduced to the lowest possible level, reduced as far as possible and appropriate, removed or reduced. I mean, this just gives me gray hairs. Yeah. So thank you very much to the MDR. We have lots of good examples of how to not write requirements. Yes. Now let's move on before I get too depressed and upset with this. Here is another requirement with a much more subtle mistake. So what's the problem with this one? The XMED system shall be able to operate for more than 3 hours. Yeah, what is the problem with this one? Well, the problem is that it includes superfluous words, be able to. They don't add much value at all to this requirement, actually. But it's even worse than that, because when you use be able to, which I recommend you to avoid, generally speaking, it could be misleading when you verify this requirement, because it implies that under any circumstance, if you can make the XMED system operate for more than 3 hours, the requirement has been met. But that's probably not the intent of the requirement. It's more likely that under all circumstances, it's supposed to be at least 3 hours or more than 3 hours. So the way to phrase this is just to remove the superfluous words and say the XMED system shall operate for more than 3 hours, full stop. You might have a few preconditions to this one, but I've simplified it a little bit. So review your requirements, look for be able to, and see how many there are, and if you could potentially remove them. Usually you can just delete them. Now, let's see if you can spot the problem with this requirement, and that is that the XMED device must be able to deliver a flow of 100 milliliters per minute. Now, if we follow the principle that we brought up with the previous requirement, we should remove the be able to, because those words are superfluous, but there is actually one more issue with this requirement. And the problem is that 100 milliliters per minute is not specific enough. And by that, I don't mean that it should say 100.000 milliliters per minute. I mean that the R&D engineers would not know if it should be at least 100 milliliters or not more than, or 100 milliliters plus minus 2. The requirement is simply missing tolerances. So this must be specified in greater detail. And for example, it should maybe say the XMED device shall deliver a flow of at least 100 milliliters per minute. That would be the way to go. Yes, and previously I said that medical device professionals in general are missing training in this area. This is also true for notified body auditors. Thus, they are not likely to detect this kind of issues. But this one, again, is one thing that they might detect or react to, because once again, it looks like the acceptance criteria is missing. So that is a good point, or something to really observe. If you turn to requirements engineering, this is not so much about acceptance criteria, but actually part of the characteristic of having complete requirements, which once again is mentioned in the ISO 13.5. And when a requirement is not complete, it doesn't stand on its own. It's simply missing information. And both requirements engineering best practice as well as the ISO 13485 will require requirements to be complete. Let's say here is another poor requirement. The requirement is that while the XMED device is connected to the compressor, it shall produce less than 35 decibel a sound measured at 1 meter in front of the device. So what's the problem with this one? It has a precondition. There is nothing wrong with that. It's that the XMED device is connected to the compressor and it shall produce less than 35 dBA. There is a tolerance and there is a good unit. Now, we could discuss whether there should be a tolerance to the 1 meters, but that's actually not the big issue here. Now, the big issue here is the it. This requirement is using a pronoun. And it says that it shall produce less than 35 dBA sound measured at 1 meter in front of the device. And that refers back to, yes, that's the question. What does it refer back to? The XMED device or the compressor? We can't tell, right? So one should really, or both for that matter, we should really try to avoid using pronouns to make it very clear what it is we're referring to. Keep in mind, you know, if you're writing a short story or a novel or something, or just an email, you would want to use it because you don't want to regurgitate the words and terms over and over again. But here you need to think of requirements more as if you're writing software code. It's perfectly okay to repeat yourself to make it accurate. So the right solution would be to say, while the XMED device is connected to the compressor, the XMED device shall produce less than 35 dBA sound measured at 1 meter in front of the device. Yeah. So this requirement was actually not complete the way it was from the beginning. Now, last example for today. Let's see. Patient temperatures below 33 degrees Celsius shall trigger a high priority alarm. What's the problem with this one? Well, it does have tolerances. The temperature is specified using a clear unit. It includes the shall. That's important. There are no pronouns. So what is the problem? Well, the problem is that we can't tell who or what should trigger the alarm. Is it the nurse? Or is it the device, the software? So you should always try to include a subject in a requirement, meaning do not use passive voice. So in this case, now we've added that if the patient temperature is below 33 degrees Celsius, then the so-called device shall trigger a high priority alarm. Now, there's no doubt about it. It's not the nurse, it's the device that should do it. And that is also important to keep in mind, to always have the subject in the sentence. And for those of you who are engineers and thought that you would not have to do grammar or language or anything like that, that's why you chose engineering. Well, requirements authoring is not the right choice then, because this does indeed require a little bit of language skill and grammar. So to summarize, I'm nearing the end here. What we've talked about so far is that I've concluded that more should be trained in this area. There are way too many people that have received no training and then they're just put to write requirements, which is not fair. I think one should be prepared to do that kind of job. And that's true both for those authoring the requirements and medical device manufacturers, as well as for notified body auditors. Another important point that I've tried to make is that requirements have to end up in the right buckets or cups, if you like, because different requirements are processed in different ways. So don't mix them up and don't duplicate them. Make sure that they run through their own processes. That's by far the smoothest way. And lastly, how to write requirements. We've touched upon a number of these rules now and exemplified them and said, well, this makes the requirement ambiguous or incomplete, and a few tricks on how to improve them so that they will take you through the product development without a hassle. And hopefully a few of these quick things we've gone through will help you write a little bit better requirements in the future. That's what I'm hoping for. So I think soon I might be receiving a few questions from Carl. I hope you've posted a few questions, or maybe call if you have some statistics on whether people have training or not. But I once again want to encourage you to connect with me on LinkedIn and check out the requirements engineering course that you can see the URL of here. It's launching now, 3 minutes ago. It was launched on medicaldevice.hq.com. And I'm hoping to see you on that course. And that was all I had to say as part of my presentation. And then it's time for me to, well, thank you for the attention and hand over to Carl, I believe.
Thank you very much. The chat is bubbling with questions. I urge you to stay on for a while and address them. I'm going to throw out a couple in your direction here. People are very interested in how to formulate the requirements, and they seem to come up with counter examples for almost every example that you show. And I'm sure that you want to engage in those types of discussions. And I'm sure that in your course, you will teach participants tricks and give them tools to deal with these things on a more abstract level. Am I correct?
Yeah. And there are plenty of paths you can choose. I mean, now we haven't had the time to touch upon that. For example, I personally like to write user needs using a pattern, which is really like a syntax for requirements that is generally used in Agile. So I use user stories to write the user needs. And when I write design input requirements, I typically use a pattern from ears, which is a method where you have like 5 different patterns depending on the conditions. You have while or when or if or where that you add to shall statements. And there are different schools of thought on that, obviously. But yeah, the ones that I've showed so far here are pretty straightforward and would be generally quite well accepted, I believe, according to most principles.
Yep. So the first question you got, and this is the golden one, and you need to tell me if you want to dive into this. So one asks, could you please give a clear definition of design input versus design output? Do you have a go-to answer there?
Yeah. So the thing is, there is actually no there aren't any good definitions in the norms and standards, but I can definitely bring one up here. So let me open this up for you, and this is in the we'll be looking at this now in a flowchart software. Apologies for that, but I think you cope. So what I've done is that I typically try to use definitions from standards and norms if I can. The problem is that if you take design input here, it means the physical and performance requirements of a device that are used as a basis for device design. Now that's from the QSR or 21 CFR 820. Do I think this is a good definition? Nah. Not really. I think there are better ways of expressing it. So what I have here is my suggested definition based on INCOSE guidelines, and then it's been tweaked to suit the medical device industry. So I would say formal textual statements that communicate in a structured, natural language what a medical device must do to realize the intent of the needs from which they were transformed. That is the definition I use for design input requirements or design input. And design output is properly or quite properly defined, I would say. Let me see if I can scroll it over here. No, what's wrong here? Or for whatever reason, I can't. There we go. The result of a design effort at each design phase and at the end of the total design effort and so forth. And that's also defined in the QSR. Those are the definitions I use for that.
Yeah, they will come in very, very handy. Do you have any opinions on constraints? Sometimes constraints are written down, and they have a tendency to become using negations sometimes.
Yeah.
We had one example here. How do I specify that my device shall not be cancerogenic?
Well, oh yeah, that's a good one. Because the thing is, so there are many things to be said about that. Firstly, that's not a particularly good requirement because you cannot verify it easily, can you? So, and we in the medical device industry, we are writing that left and right. You know, shall be biocompatible. But if you were to make that really good, you would quantify it and say that, for example, the amount of leachables shall be limited to less than. And I don't know what kind of unit you would use for that because I'm not a toxicologist. But then you have not used the negative requirement. You said we limit the leachables or allergens or whatever it might be to a specific level. And then you can give that requirement to the engineers who would then be able to implement that. Because the problem with saying it's not going to be carcinogenic, what are the engineers going to do about that? I mean, how are you going to select your plastic materials? I mean, if you're a mechanical engineer, you do not know what is carcinogenic or not. The transformation of needs into design inputs should not stop until just about any engineer could be implementing it, meaning you don't need to be a biomedical engineer or anything like that, or half doctor, medical doctor, or half toxicologist to do it. So that requirement, and I know it's not easy. I don't have like, oh, I can give you the numbers. It's not that easy, but that requirement shall be biocompatible or shall not be carcinogenic are far from complete, and much more work should be going into that kind of statement.
Brilliant. We have a couple of people that ask about system and software requirements from IEC 62304, whether they should be regarded as design input or design output. I have an opinion. Do you have an opinion, Peter?
So, yeah, the system requirements, without a doubt, they are design and development inputs. Now, you could argue then that the subsystem requirements are design outputs. And I would agree that they are, but they're also design and development inputs. Because if you read, for example, the design control guidance document from FDA, they have almost like a philosophical approach to it, where they say, first you have an input that becomes an output, that becomes an input, that becomes an output. So you are sort of iterating on that. Now, that might not be the most practical thing to write in an SOP because it gets totally confusing. So if you ask me, I would say, generally speaking, I would say subsystem requirements are also design inputs. They should be regarded as any design inputs that you develop the device based upon.
Yeah, I can also let you know that Christian Kestner is hijacking the chat here and answer all the 62304 related questions for you.
That's good. Yeah, yeah. He's trusted. Yeah.
Brilliant. Yeah, one participant asked you, how about pitfalls of writing user needs? Isn't the nature of something to be validatable different than verifiable?
Oh, sure. Yes, absolutely. And there are plenty of pitfalls in that. And let me put it this way. If you have an auditor that is super strict about how that all user needs should be validated, and validation is always in a simulated or real use condition and using production units or equivalents. Let me take one example. So you say 99% of the population shall fit in the device, or whatever we say. How are you going to validate that? Well, that's going to take a lot of people, right? 99%, that's a bold statement. And you're going to have people that are really tall or short or, heavy or lightweight. All of them, you're going to have to run through that validation. Makes it incredibly expensive and difficult. So sometimes you simply have to be a little bit smart about how you phrase your user needs. Maybe you should say that it should fit the adult population, and then you work out the details while you transform the user need into design input requirements. And out on the other side, you say, well, it needs to be 400 millimeters wide or larger. So then you use it on adult people in the design validation, and the details of it, you work your way through while you transform the user need to design inputs.
Yes, ladies and gentlemen, you understand what I say when I mention that Peter always gives you an answer. There's no it depends here. There's straight answers from a straight shooter. I really appreciate that. Please hang back in the chat, Peter, and interact with the participants. They have a lot of questions that you can answer a lot better than I do. I want to reiterate once more then. Feel free to hook up with Peter on LinkedIn so you can enjoy the offers and the new courses that he consistently brings to us medical device professionals in this industry. And don't forget to use the promo code aligned_MDHQ to get access to the free, for you, the participants of these events, the free course, Introduction to the Medical Device Industry. Peter, thank you very much. Always a pleasure.
Thank you. Thank you.